Well, hey guys, how you doing? It's me, Chris, back with another Blue Screen Talk Show. Please don't mind the mess. I'm rearranging in the house and things like that. I don't move. I just move things around in the room. Anyway, I'm here to talk to you guys about, well, diamonds. Girl's best friend, right? Well, guess what? Apparently, actually, the next best thing for a power source. That's right, ladies and gentlemen, they have discovered how to build a diamond battery. And this is over in the UK. University of Bristol. They figured out that if they took a diamond and they put it in proximity to something radioactive, it would emit electricity. And so they said, okay. So they tried it with tried nickel-63, which is a radioactive isotope. Man. Then, I mean, it's good for prototyping, but they needed something long-lasting. Well, you know what? Emits a crap ton of radiation, and we have a lot of nuclear waste. And that is what they did. They took the carbon-14 rods that were expended from nuclear power plants. They did a process by which they heated up the carbon-14, and they extracted a lot of the radiation in the form of a vapor. Took the vapor, condensed it down, and well, what happens when you put carbon under a lot of pressure? Diamond. So they made a diamond out of the carbon-14 vapor that had a good amount of radiation in it. It emitted electricity, right? Well, then this thing was still hot. I mean, radioactive, So they encased it in, yes, another diamond. Think about it. We have, let's have a see here. Yeah, Google gives me 5 million tons. 5 million tons, guys. If we can make a crap ton of these diamonds, we can not only solve our problem of nuclear waste, but we've also made an amazing battery that'll last about 5 million years, or 5,000 years plus. 5,000 years, guys. Can you imagine this? 5,000 years. Okay, so what practical use for a 5,000 year battery is there? Well, I'm glad that you asked such a question. Well, think about this. Them satellites we put into orbit, I know, they're solar, they're up in, they're unimpeded, whatever, but those batteries go bad, right? Because the solar panels take in power, goes into the battery, charges the battery, and back into the thing, right? Or probes that we like landers we've sent to Mars. Okay, well, they only have a half-life of so long. But we've gotten a lot of mileage out of these things. Okay, so think about this, right? A lot of it has to do with the ability to power the electronics, because the solar panels on the machines will get covered up by dust. Okay, fair enough. Subsequently, it will kill the machine, not because anything fries, but because batteries will not be able to recharge. Put a nuclear diamond, or nuclear, whatever, diamond battery, nuclear diamond battery in one of these suckers. We can have it on there till literally it falls apart. Like literally the diamond will outlast the machine. And the best part is, say we send something and it blows up, it ain't gonna blow up. Because why? Diamonds are the hardest substance known to man. I mean, you literally, like tungsten and stuff like that, very hard metal. You know how they mill it? With a diamond bit. Okay? So you need another diamond to basically get into the middle of this diamond. You know, so we're talking, if something goes wrong, the machine will blow up, but it'll be okay. Let me think. Unless it goes into a sun, but who cares at that point? I'm just saying. What else here? Think about interstellar probes. They will eventually get out of the range of our star. No longer able to get light. You put something like that in them, they will be able to still outlast it will still outlast its components. Voyager 1 is just gotten outside of our solar system as of a year ago, which is pretty cool, right? For what we got going on, pretty cool. Someday its power source will fail, right? The reason that it's still going, though, is it's got a nuclear core and it's still going. And we use the most rarest isotope on Earth that can create nuclear fission to send these things. I ain't the problem no more. You know, we want to create something that could generate enough power for warp. You know, which is a real thing, right? I've talked about this before. They're actually talking about, and they've done tests, simulations where they can, but it would take a crap ton of power. Build a diamond big enough. We have enough carbon-14 rods that have been expended. Build a big enough diamond or a diamond bank. You know, you could, throw out, a couple hundred megajoules of power. Or not megajoules, gigajoules. It would actually be in the giga to actually create a magnetic field strong enough to warp space-time. And this excites me. And it should excite you too. But what's really cool, though, guys, is to see the barrier being broke or attempted to be breached. Because batteries are, I'm sorry, they're old technology, guys. They are, we have 9 volts that run stuff like, our heat or temperature gauges. We have batteries, lithium ions that run our phones and tablets and laptops and whatnot. We're now having problems now where the lithium ions are combusting. I still say, though, somebody tampered with the original recipe to make it a little extra tasty, crispy, and it sort of kind of went awry. I really think that for space travel, this is going to be perfect, especially if we get in the outer reaches. You know, in areas where starlight, you know, photons cannot hit solar panels enough to charge batteries to run a ship. I mean, a ship that will, what, create gravity? Yeah, I'm thinking big. Okay, just saying, I'm thinking big. A ship that can A create gravity, create gravity, B oxygen, environmental controls like navigation and stuff like that. You know, stuff that is really, really critical when you're out in space. It's gonna be really interesting, or not interesting, but what's funny is like the dilithium crystals on Star Trek. We have dilithium crystals, guys. I mean, they're actually more powerful, I believe, now. I mean, like, they're doing small ones, so they're not as powerful, but you can make them or bank them, and if you can do that, dude, we're good. I honestly, I do hope that they can do this, because, you know, battery companies are going, oh no, they'll put us out of business. And I think in some aspects the role of the battery will just be reduced, you know, because, like I said, our devices are getting more and more power hungry, you know. But stuff like this, you know, all I need is a 9 volt to run it, you know. I just do that, and I can do that and take a reading and be done. It shuts off and I go, okay, you know. Or I don't have anything else on me that is low power consumption. Oh, my network tester, you know, it takes a 9 volt. It's low power consumption, you know. All I needed to do is be on, tell me that things are or are not functioning properly, and then go fix it. And I'm okay with it. I really am. Electric cars. Electric cars. The thing about that is that now we have a way. Now we have a way to make electric cars perfectly suitable and in direct competition to a internal combustion engine motor, or even a diesel fueled motor. Because up till now, what we've got, trains that run diesel electric. We've got trucks, you know, like the big 18-wheelers that they're starting to go diesel electric. Why? Because they use the diesel motors as a generator, and then just have it set at a certain RPM that's efficient. And any hybrid, they just set it at an RPM that's efficient. They throw power into the motor, and it works. And I don't knock it. I don't knock it at all. But it's amazing to think that within my lifetime, your lifetime, you will possibly see, I will possibly see a day when I don't need to change a battery. Like I said, I am stoked about this battery. I really am. I'm ready to shed lithium-ion batteries. I'm ready to shed lead-acid batteries and all that. Just get rid of them. Get rid of them. At the same time, we actually can do something real to help our environment. Real. Because keep in mind, the stuff that they have to put these in will start to degrade. Its nuclear, or before its radiation is expended. So, you know, number one, it costs money. Number two, it's gonna be a big hazard Why? Because of spillage. It'll leak out. It has leaked out. Not me saying it. You can look it up on Google. There's big problems with it. This answers a lot of real world problems. And at the same time, allows us to continue using nuclear energy. Which is actually, well, I won't say efficient. It would be more efficient if they actually did work on the turbines and made them more efficient. Then it would actually be a truly efficient way of producing power. But I'll take a nuclear battery out of the deal, or diamond nuclear battery, or whatever we want to call it, right? Anyway, guys, thank you for watching. Tune back in. First video I put up on this channel. So tell your friends, tell your family, like, dislike, don't hate. No, I'm kidding. Well, please, don't hate, but give me constructive criticism. This is the first video on the channel. So, my other ones are on my Load Failure 404 channel. And go check me out on Load Failure 404. Like my page on Facebook, you know, and obviously talk to me. Alright guys, thanks. I'm gonna shut up. Have a good one. Thanks for watching.